In this video, we're going to learn how to solve equations by using our knowledge of rational exponents. So what we're going to do for the following problems on the screen is we're going to use our knowledge of roots and rational exponents in order to solve these equations. So our goal in each one of these is to get the part with an exponent by itself. So here you can see we have an x squared, we have an x cubed, and we have an x to the sixth. We always need to start by getting that piece that has an exponent by itself. So in this first problem, I'm going to start by simply adding 5 to each side. Now as I do that, I end up with x squared is equal to 144. Now the way to undo an exponent here is to utilize a root. So if you see an exponent of 2, a root of 2 will undo it. And that's because a root of 2 really represents an exponent of 1/2. And just to kind of give you an idea of what's happening here, so if we take the square root of x squared, that's going to result in x. The reason that is happening is because that root 2 is really an exponent of 1/2, if we were to write it using our rational exponents. And when we have powers raised to powers, we multiply the exponent. So this becomes x to the power of 2 times 1/2. Well, I know that that becomes x to the power of 1. So that's why we can use roots to undo those exponents, because roots become fractional exponents, which then result in those powers being multiplied, and then the x value results in a power of 1. So here, in order to undo this power of 2, we're going to use a root of 2. So I'm going to put my root in there and add in the 2. And remember, whatever I do to one side, I also need to do to the other side. So here I know that on the left-hand side, I'm going to be left with x. Now, for this one, you could utilize a calculator, but we know that 144 is a perfect square. Square root of 144 is 12. Now remember, we always have to be thinking, do I utilize the plus or minus here? Because we square rooted a squared here, and because this has a root 2, the square root of 144, because it's even, does become the positive or negative version, because a positive 12 squared will give me 144, and a negative 12 squared will give me 144. So for some of these will work out really nicely because they'll be roots that we already know the value for. Now if we look over here at the next example, we look at example 2, I notice again that I need to get this piece that is cubed now alone. So I'm going to start by dividing each side by 5. Now 3,650 is a slightly larger number, so I'm going to use my calculator to help me, but 3,650 divided by 5 results in me getting x cubed is equal to 730. Now from here I need to undo that cubed. In order to do that, I use the cubed root function, and if I do that to one side of the equation, I also need to do it to the other. Now remember, that cubed root function really becomes a power of 1/3, and when multiplied with 3, that results in just an x value on the left-hand side. Now 730, at least to me, is not a number that I know I can easily find. So I'm going to turn this into a fractional exponent here. This is really 730 to the power of 1/3. So I'm going to plug that into my calculator, 730 to the power of 1/3 in parentheses, and I end up with a value that is close to a perfect number, but I can see that it definitely isn't perfect. So here I can see that if I round to 2 decimal places when appropriate, I get x is equal to 9.00, because that 4 after the second 0 does not round it up. Now from here I have to decide, is this a plus or minus situation? Because this is an odd root and an odd exponent, I do not include the plus or minus. Now from here, this is a little typo, this should be a positive, so you can go ahead and remove that out of there. So we have 2x to the 6th plus 12 is equal to 6,252. So again, we're going to go through this process of solving this, and we're going to start by getting the piece that is to a power by itself. So we start by subtracting 12 from each side. So 6,252 minus 12 results in 6,240 is equal to 2x to the sixth. I then divide both sides by 2, and I end up with x to the power of 6 is equal to 3,120. Now, as far as I know, that's not an easy one to figure out in my head, so I'm going to use my knowledge of roots to help me out here. So because this is a power of 6, I'm going to utilize the root of 6, because that would result in a fractional exponent of 1/6. So when multiplied with 6, that would become 1. So on the left-hand side here, I'm just left with an x value. Now if I also take the 6th root of 3,120, I know that I can rewrite that as 3,120 to the power of 1/6. So I can enter that into my calculator, 3,120 to the power of 1/6 in parentheses, and I end up with an x value that is approximately 3.82. Now for this one, I also have to decide, is it a plus or a minus situation? And when I think about it, I notice that this has an even power and an even root, which tells me that it is a plus or minus situation. So I need to give myself a little more space here, include the plus or minus 3.82, because 3.82 to the power of 6 would give me 3,120, and negative 3.82 to the power of 6 would also give me 3,120. So for these two problems here, we're going to apply the same idea that we applied on the previous slide, but you'll notice the problems look slightly different. You'll notice that we have an entire quantity, so in this case, x minus 1 to the power of 5, and here we have x plus 3 to the power of 4. So what we're going to start doing in each of these is we're still going to start off by getting the piece that has the power by itself, but this time it's not just going to be like a singular variable by itself. It's going to be the whole quantity, x minus 1 to the power of 5 by itself, because we can't just take that negative 1 out of there. We have to actually undo the power before we can solve for x. So here we're going to start off by adding 8 to each side. So I have x minus 1, all in parentheses, to the power of 5 is equal to 228. So from here, my next step is I need to undo that power, because I can't really take anything out of there until that is gone. To undo a power of 5, we use a 5th root. So I'm going to apply a 5th root to each side. So then from here, I have x minus 1 left on the left-hand side, because the root and the power undo each other. On this side, this is really 228 to the power of 1/5. So I'm going to plug that into my calculator, and I get a value of approximately, when rounded to 2 decimal places, of approximately 2.96. And then I have to remember, okay, do I use a plus or minus or not? Well, when I look here, I notice odd root, odd power, so I'm not going to use the plus or minus function here. As a result, I simply need to solve for x by itself, so I'm going to add 1 to each side, so I end up with x is equal to 3.96. Now if I look at the second example here, again, my goal is to get that piece with the exponent, so the x plus 3 to the power of 4 by itself. I'm going to start by subtracting 5 from each side. So I have 4 times x plus 3 in parentheses to the power of 4 is equal to 400. And then I divide each side by 4. So I end up with the quantity of x plus 3 to the power of 4 is equal to 100. Now if this had a squared, I would be able to evaluate this pretty easily. Unfortunately, this is to the power of 4, and off the top of my head, I don't know anything to the power of 4 that will give me 100. So I'm going to need to take the fourth root here because the fourth root undoes the fourth power. So then I'm left with x plus 3 here on the left-hand side. Well, this really becomes 100 to the power of 1/4. So if I take 100 to the power of 1/4 in parentheses, I end up with 3.16 rounded to 2 decimal places. And then from here, because I have an even root and an even power, I am going to include the plus or minus here. So what this means is I need to remember that a positive 3.16 to the power of 4 and a negative 3.16 to the power of 4 will both give me 100. Now, my last step here is to get the x by itself, so I subtract 3 on each side. So I end up with x is equal to plus or minus 3.16 minus 3. Now this really isn't a good way to leave our answer. We do need to take it one step further and figure out, okay, if I have the positive version, so if I have positive 3.16 minus 3, what would that be? Well, if I have a positive 3.16 minus 3, that gives me an x value of 0.16. And then if I do the same thing but look at the negative version, so I do negative 3.16 minus 3, I end up with a negative 6.16. So in this case, I have two values for x that if I were to take them and place them back into this original equation, they would make that original equation true.